Welcome, welcome. Uh, so yeah, I think we're still working on getting things, furniture and sprites to show up properly rotated. Uh, and we got some more work to do. Um, I'm already looking at the diff over here. So what we had a change in flight here. Um, yeah. What does our log say of the test? I think I ran it up here. Go to render. Yeah, so here are the three pillars in one of these rooms. This is like the top corner. This is like the left corner, and this is the right corner. So this is not far. This is pretty good, and this is pretty good. This is wrong. And what size is the screen? I forget if this is off screen or not. But this is very close to the. Like, that's too far towards the viewer. Shouldn't really matter what the Z location of the floor position is because we don't pass it in, right? We pass in a Z0 here. Uh, what is the GL state? Slash, I'm pretty sure we're logging it somewhere. Yeah, after reordering. So before we enter this loop, the GL state is this, which to me looks like OpenGL does column major order, I think. Um, this is just a translation. What? I mean, like, there's no rotational component of this, right? Like, there's a value in 0, 0, and nothing in the rest of the column. Then a 1, 1, nothing in the rest of the column. 3, 3, and then hmm. I mean, let's say that that's the matrix, right? Then when we go to render at 335, 599, 406, or I should say 335 and 599. trying to think, what is the way to understand what we're trying to do and understand what we're actually doing? Um, it's been a while since I looked at this code, like a week or so, and it's was hard to look at before, but it's really hard to look at right now. Um, we're just using this junk to get this like floor position. Um, where are my fingers? What is the total model view that we start with? Also, this can be extracted. We don't have to do it every time through the loop. Um, I mean, I guess it's what it's going to be from the GL state, right? It's going to be the same value that we saw from before. That makes sense now that I think about it. So let's not bother logging it. It's just noise. So what's I stand up? Instead of logging and trying again, let's just use the debugger. We'll break right here and let's break right there and then inspect things to see what the what. What do we expect to see? We expect to see that we come in with the stand-up matrix multiplied into the orthographic projection matrix. The stand-up matrix is what accounts for the viewer position and zoom. So that's why it's diagonal with a translation. Okay. We didn't set a breakpoint yet, so it's not going to break. It's just going to fail. But we'll break on room.go line 316. So let's see what we can see here. The stand-up matrix is like given a position in like room space, board space, move it to account for the zoom and translation of the viewer, right? And so the viewer's at like 50-50 or something. No, because of the zoom, we're gonna scale up by 50, and then that's whatever you give it, it's gonna add 262 to it. So that means move the viewer left and move the viewer down. The floor matrix is 35. Eh? That doesn't make sense. Um, no, it kind of does. Okay, so the floor matrix, you got to think of it as the transform to go from the board space to uh, screen space, really, because it's the orthographic projection that does screen space to normalized device coordinates, which is the value that OpenGL actually needs at the end. Okay, and this is saying stretch and rotate. Hold on. 1, 2, 3, 4. So the second column is 35, 16, 31, 0. And then 0 minus 44, 23, 0. That's saying that as the Y component in board space increases, the Z component decreases. Yes. Those points move further away from the viewer. Okay, yeah. Okay. And then, yeah, 512, 217. 1024 by 768, but then adjusted by some kind of Y offset. I think, maybe? I don't know. And then where's the stand-up matrix? So we expect this to be the orthonormal or orthographic projection multiplied by stand-up. How can we decide if these are correct or not? If we use them to render big objects and see what they do, see what they make, or like unit vectors. I think I also want to understand where the viewer is, or at least thinks it is. So this is saying focus at cell 5, in the room, and I think it's a 10 by 10 room. Yeah, zoom by 50. And render across at 1024 by 768. what did we actually change? Now we're passing in the room mats. We're not casting a thing. We're renaming FXFY to X in room, Y in room. Uh. If we have a 1024 by 768 screen, this should be on the screen. What test are we in? Host test. Oh, I guess it didn't capture room ID, did it? Ugh. Um, how do I want to do this? I guess we could have just gone up. right, on the stack. Okay, let's break again on cheese washer. Be right back. Thought I had some gum in here, but I don't. Why? No, we can't go with the stack because it's on the render thread. Um, too many guarantees. Hey, Advisor7. Welcome. Welcome, welcome. How you doing? I'm trying to see which test is actually running, because that is not clear to me right now. This is like the driving go routine for the tests, not the one I care about. All right. I'm looking for roomtest.go. I think it's this one. GR43. Yeah, here we go. Tutorial dash entry. All right. So that means it's this one. So we're trying to draw the pillars. Yeah. But instead of having them like off to a wonky angle, we're trying to have them stand up. So this is supposed to be 1024 by 768. This position, we're expecting 372, 222. Is that from the top or bottom? This one is lower, so it should be from the top left. Well, whether it's 222 from the bottom or 222 from the top, it's still on the screen. Um, and then what was the routine that we were working on? Whatever it is, it's going to have line number 316 in it. So use that to look for it. Go to 6. So 335, not particularly wrong. 600 seems wrong. But 768 minus 222. Closer, but not, still not right. Clearly, we need more coffee. Mm. This is not ideal. Okay, it's because we're at this step, not at this step. Basically, we try to draw it once to like kick off texture loads, and then we clear the screen and draw it again to actually draw it. So let's toggle 1 so as not to break out on it anymore. And then we'll add a breakpoint for here. We'll run it again until we hit the breakpoint, and we'll toggle back 1. We don't need 2. Okay, so now wait a minute. Did we actually queue the textures to load? Is it just the textures aren't loaded? No, this DX is okay. This DX is the board space dimensions width of the unit of the entity or of the pillar, which is like extra annoying because this width depends on the whether you're talking about this width means different things whether you're talking about things along the floor or things drawn on top of the room. Because why not? So hold on. It used to be that we drew everything along the floor. And then we changed it so that it was drawn standing up from the floor. Let's test with drawable. It might be that we need to look for that test. So wait a minute. Oh, hey, crazy. What did I do with quantum computing? I worked for a company here that actually builds quantum computers. I was mostly working on like microservices and user-facing stuff in the classical realm, just to manage jobs and such for people who wanted to submit jobs to the quantum processor. Um, it's a company called Anion. I forget if they're .com or .ca. AnionSys.com. Used to work for these guys. Did a little bit of work on their Julia SDK for uh, the actual jobs that researchers and scientists would use to describe the circuits they wanted to run. But yeah, they do a lot of their shtick is like they do everything in house, and so they have control over the whole pipeline of components that go into making a real quantum computer. It's still only like you know dozens of qubits. Uh, it's all public, I think. How many qubits is which, but um, yeah, like they manufacture uh, the superconducting. What do they call it? There's a name for the type of qubit or the type of physical uh, implementation for their qubits, but basically they give you qubit level access to their chip, and but they also manufacture the cryogenic freezer that it's got to sit in because it's got to be close to absolute zero to be superconducting, and then they also design the electronics that are used to send the signals in and read the signals back out through uh, through the fridge. So it's they do a lot of different things at a very uh, in-house style, and so they can not deal with the lag time you'd get if you had to make a breaking change to your cryogenic design. Right? You just talk to Billy over there, and he'll work on a new fridge for you or a workaround for you. But as with most things, quantum computing, still very early stage, very much research and development oriented. But it was a very cool company. No pun intended. um, that's where I picked up Go, actually. The microservices in the back were all Go. Okay, so this is not half of 768. Where's 375 coming from? Oh, 375 is the position vector that we passed in. I guess 375 is probably half of 768 adjusted by the delta you'd get by tipping the floor. How is it making a gaming Go? It's like most projects, it's more dominated by the designs and choices of the developers from before, and less really bumping into the limitations or the features or the isms that Go inflicts or requires. It's this project can be quite painful at times because there's a very scattered and unregimented, irregular way of going about things. For example, they used to just like mess with the GL state. Like they would set features on and off just in the moment and do their thing and then return. And they wouldn't clean up after themselves. And so I get the sense that they did a lot of manual testing of what does it look like when I actually run the thing, but they had no way of testing little individual pieces. Um, so I'm running into a lot of problems with nothing's been written to be reusable. Nothing's been written to be used in any context other than the specific context they were originally used in. And I think because they had a lot of pieces like that, they ended up copy pasting a bunch of stuff that was close, tweaking it for the new special case, and just running with it. And it's like you have 6 or 7 things that all look the same, so it's confusing to keep them separated mentally, but also it's like I need to refactor this and get rid of this duplication. It's awful. So that it's in Go hey, I get to use Go, and I like Go, so that's good. Um, that the project was in the state it was in when I picked it up, that's the real challenge. And I think most projects I've worked on, that's really the challenge is trying to wrap your head around what the heck people were thinking before you got here, or what the heck you yourself were thinking 6 months ago. Um, that's really the barrier to understanding and making progress. I've found. Crazy, you were the one working on their masters, right? And you have kids. Now I understand the username, but how are you doing? Just super busy? Are you avoiding again? Yeah, just waiting for the wife to pop. Well, congrats. Best of luck. I know you've been through it, but it's never gonna be easy. Just enjoy what you can, I guess. um, but yeah, I'm trying to think. We used to draw this, and now we're drawing this. Now I like the that we've improved the orientation of this thing. Um, because the main goal is to not draw this guy flat down on the floor, but draw him standing up and like facing the camera. Um, so I think that's what this is the right direction. I'm not convinced this is the right position. Um, the yellow on the screen in the game, is that like a flashlight? No, that's just a a debug entity trying to just draw a triangle with known geometry and then see where it lands. And the test is to make sure it lands where we expect it to land. It's not in the game so much as just in the test. Yeah, and school starts again tomorrow. Stressed, haven't even started yet. Ugh, I hear you. I still get stress dreams about school. It's always like it's like the first week or two, and I don't remember what my schedule is, and I gotta like scramble to find the classrooms that I have to be at, and can never make sense of the online portal that I try to log in and check the schedule because it's a dream, and online portals never work in your dreams. Yeah. What is this saying? This saying go left of center by half the width and below center, then go left of center above center, and then right of center above center. Don't worry, they don't work awake either, right? Now, hold on. The let's let's break on here. Line 30. Like dx is 10, right? Yeah. So we're sending the geometry -5, -5, -5, -5 plus 5, plus 5 plus 5. And we end up with this. We used to end up with this. And this makes more sense to me because -5, if you think about like y 0 at the bottom corner, x increasing as you go to the right, y increasing as you go to the whatever. This is the center of the room at 5, 5. And then you go I guess it's not. This isn't really right either because this would be -5, -5. And then we went to -5, 5. That's correct. And then that goes to 5, 5. Oh, okay. Yeah. Okay. But then here, -5 is like down here? Here, squint with me. Squint as hard as you can, and maybe that'll make sense. Harder. Squint harder. No, it's not going to work. Okay. Squinting is not going to work. This is 5, 5 in the room. This would be something like -3, 13. You're always squinting. How did I know? What's really going to get you is, did I know that squinting wasn't going to work? Oh, okay, okay, okay. So the matrix that encodes the transformation from this geometry to screen coordinates. The old one did the basically take the rectangle that was this quad, twist it, and then tip it back, right? And this one is only adjusting based on where the viewer is located and the zoom of the viewer. But like I think the scale is very different between those two transforms. Like the scaling factor that you'd need to shrink the room by with the tip back is a more intense scale down than just the translation zoom. Like at the end of the day, this is the matrix that transforms the input geometry into the normalized device coordinates, right? So the input geometry sends -5, -5, 0, 1. -5 times 0.09. Minus 0.0488. So that's pretty close to 0, but it is left of 0, which means it should be close to the middle of the screen, but to the left of it. Um, but we should also account for the translation. We have to subtract another 488. Yeah. Yeah. So that's saying a quarter of the way from the left-hand edge, which is not at all what we're saying. It's pretty fun only getting here once or twice a month because each time I'm completely lost on how far this project has come. Yeah, yeah, I haven't made much progress, I think, in the last month or so, but um, I'm not sure if the game's in a state where I can just download it. Let's try. Yeah, we've we've had to regress a little bit to make the next steps, but we can like zoom and stuff. For some reason, zooming has become a lot less uh, responsive. But if we zoom far enough, I think we panic. Must get closer. Must get closer. 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 It actually looks like a game. Yeah, kinda. And then if you zoom way out, it we go to the upside down. um, right now I'm zooming out, and it's gonna go closer. So that's fun. I think it's some kind of wrapping issue, but maybe that's an Easter egg. If you zoom too far out, you go to the upside up to the upside down. Yeah. There's no exit. There's no escape apart from Control Q. But yeah. Um, it was looking a little bit better slightly before this version because I didn't break a bunch of the drawing to try to get it to draw nicer. Um, but yeah, hopefully we can get that fixed. Okay. So I'm confused because this sends a -5, right? -5. It gets multiplied like -5, -5, 0, 1 gets multiplied by this matrix, which is in column major order. So it's like -5 plus 0 times 0, or sorry, 0 times this -5 plus 0 times, wait, what? X. 1, 2, 3, 4. The Z column. 1, 2, 3. Oh, okay, yeah. This is like the zoom out by 50, or zoom by 50. Um, but the Z component's 0 anyways. And then X gets a flat minus 0.488. But that sends us to a minus 0.53 in normalized device coordinates. Normalized device coordinates range from -1 to +1. So minus 0.53 should be about the middle, like a quarter of the way from into the screen, right? So I was expecting something along here, and there ain't nothing there. Hold on. Hold on. Like position doesn't actually enter into it. It's just logged. See, that to me looks like the center of the screen. This is half of 768. Um, I guess this is a problem that's more complicated than just one shot it. So I'm gonna have to break the problem down into smaller steps that I can actually walk through in my head here. I feel like this is not the first time I've come to this conclusion and then said, no, but it can't be that complicated. But, oh well. So, let's see what of anything in this change we want to keep. Some of this naming, but not casting to board space unit when it's already a board space unit. We'll drop all of this and just render the near x near y. I think I do want to, well, in TDD fashion, we shouldn't add code that we're not requiring to actually make the thing green. What's the easy way to do this? Yes, yes, add that. Yes, add that. No, don't add that. Edit this. So the test should still fail, um, but I hope they look different. If you don't know how to fix it, write the test first. Yeah, it's just hard if you don't know what you're testing it for. Yep. Um, yep. Okay, yeah, so right now, the things stand up. They're just in the wrong position. We might do well to focus on this test or this test to understand how we're positioning things and why it's a problem. But also, just how much better or worse is it this way? Ooh, that's fun. Okay, can I feel around to understand how they move? Going to the right moves it down. Going to the left moves it up. Going up moves it right. It does make the game more spooky, but only for devs. I'm trying to line up these bookshelves with this room. It's hard when nothing makes sense. Now, is it this room or is it? Uh, this is a game in and of itself. Bah, crash. We don't want that. So this is screaming to me that we're trying to use reflection to read things from the registry, like from data files on disk. And I changed the type in some structs, but somebody is still expecting a slice of two or an array of two ints, but they're getting an array of two board space units. And even though board space units are in fact ints, um, reflection is picky enough that it sees them as different types, and so that are not assignable. Uh, but where did that happen? This is the part of the thing that catches all of the errors that are about to leak out the top and the logs. This is the thing that actually errored. We were trying to find path. Mm-hmm. These aren't ints anymore. These are board space units. Wait, what? My hold on. This has to be an int. Um, Wall hacks. This is looking like better-ish in terms of there's sometimes people there and not white squares for whatever reason. They even like animate kind of thing. I wonder if the way to debug this is with logging and poking and prodding in game. But for now, uh, don't crash when making a move action. Really. Okay. I think this is just renaming and passing the room matrix struct into rendered drawables. So, and a little bit of logging changes. Um, clean, improve, so naming, mostly, whatever. Okay, the thing to do is, unfortunately, I can't even run just a single test right now because the way that Go selects which test to run is regex based, and I have a test room and a test room viewer. Uh, it's like the run flag. Test exclude test running. Why does this look so weird? Did Stack Overflow change how they draw things? Yuck. Change it back! I don't care. There's this. You can skip. I knew about that. It's not really what I want. Proposal accepted. Oh, I don't want a lot. Oh, merged. Okay. So it's in there. Test stars or something. Test flags? Test flag. Because why not? Skip. Okay, so if I did a go or make test run args run test room skip test room viewer. Wow, Google is so old school. The new way is type a 3-sentence query to ChatGPT and make it search Google for you just to return a wrong answer. Yeah, I'm an old man. rejects. Run this thing again. I want to see that it's only making the reject files for the tests I want to have run. Yay! Even these are standing up. This is like a dummy image put in to get the test compiling. Um, this might be the test to think about. Okay, so what did we say was the GL state and the near x near y? Yeah, GL state still looks like this kind of stretch and zoom and move, but not twist. And then near x, near y, this is just board space stuff. So if I send 914 1, well, 914 0 1 to OpenGL when this is the model view matrix, what should I expect? Um, float column major order. Okay, and then the vector was 914. 1, no, 0, I think for Z. Um, so then like this is a diagonal matrix, right? Um, have to go by 4 though. So vector at 0 times CMO 0, 0. And then vector at 1 times column major order, so the hold on. Verify that it's a diagonal matrix, right? Except for the translation at the end. So yes, it is. Very good. Alright. So vector at 0 times CMO at 0, 0, comma, vector at 1 times CMO at 1, at 1. Who cares if it's column major or row major? Vector 2 times 2, 2, and then we'll do the translation ourselves. Translated is that. Oops. It's really, plus CMO at 3, 0. 3, 1, 3, 2. So it sends it off screen. What? Doing what now? So we 914 vector 0, 9 times that. It's basically like times by 10. So that's, yeah, sure. And then 0.13 times 14. Sure. But then we have to subtract off that and that. This is like almost half a screen off the screen, above the screen. What? Gotta go enjoy stream. Thanks. Have a good one. Thanks for stopping by. I gotta use the washroom too, so I'll be right back. So if this is sending it off screen, that would explain why we don't see it. What if vector was 0, 14, 1? Also off screen, but by less. And if vector was 9, 0, 1, this is actually on screen. So this one shows up at 0.4, which is like to the right of center, and nearly down. But positionally, it should be, well, it should be along the bottom row of the room. This is the one that shows up, but it should be here. This one ended up here, and this one ended up way up there. Okay, so this like, hey, Bossy. Bossy's back. Welcome back. Wouldn't you know it, we're trying to get things, the furniture rendering correctly. Okay, so we've deduced that the pillar here is actually the pillar that's supposed to be there. I did take a break, yeah. Just kind of, life is crazy, but hopefully we can make some more progress. Um, what should this like stand up matrix look like? It can't just be a linear thing. Can it? Hmm. I've just been busy too and on a different sleep schedule. So that's why I haven't been tuning in as much. I have been on Twitch, but just haven't seen you live, so I've likely missed the stream shortly after or something. No, I literally haven't streamed for like a week. So don't worry about it. And even like the last week before that was all looking at a screen like this, being like, why isn't it in the right spot? So you didn't miss much. But glad to have you back. Um, okay. So what did this teach us? This taught us that the near x, near y being board space units, and this returns, well, this returns floats of the board space units. Um, we're still using stand-up matrix. I don't think we're doing it right. If this is the floor, then I think what happens is we draw things along the floor. Yeah. Basically, the only failure was the new test. We just didn't really see it because the reject files that were on disk were there from previous runs, not from having been made up right now. So if we look at this reject, right, things are along the floor. Now the thing about that matrix is that it will twist and tip. Like there is no linear transformation that will like fix all of the things that are on the ground right now. There's no linear transformation that will not move this position, but twist this pillar upright, and not move this position and twist this pillar upright. I need to what? I need to have a basically a parameterized matrix to undo the twist for a given for an object at a given point. So given a point, generate the matrix that will twist that geometry to be standing up. The problem with the stand-up matrix right now is that it's for only the 0, 0 value. Yeah. So what we do is yes, use the stand-up matrix. But before doing the stand-up matrix, we translate, we translate according to the, we translate such that the object we're targeting is at 0, 0. Why does that look like an owl? Why is that the first time I've noticed that? Usually I see it like that. How have I never seen that 0, 0? It looks like a freaking owl. You never know. Alright, with matrix in mode, translate by the render model. Yeah. So there's a map gl.map forward. Pointer to such. I have no idea if this is gonna work, but I'm gonna try it. Except we're still upright, which is good. We've moved, but we're not actually doing it right. So if we think about what we did from before, the pillar that was here used to be here, and then we moved it here. It's not translate by near x near y. It's translate by let's just see how if that's anything close to what we need. But yeah, near y was 0. So translate by 0 and then it's done. But let's look at the logs. The we'll need to dump the GL state here. Oh, yeah, I want to look at the geostate, not look at the results. This. This is looking very similar to. Well, yeah, of course it's gonna be the same. I had a comment recently about where I would have expected these things to show up. I seem to have lost that comment. Um, hold on. We're working on rendering the tutorial entry. It's 1000 by 1500 pixels. Okay. So the room is 10 by 15. So there's 100 pixels in the source floor for every tile. Column to black. Data furniture. Oh, that's unhelpful. it's 200 by 800. And they're saying it needs to fit into a 1 by 1. So really, at the end of the day, this piece of the texture needs to get mapped to the bottom of the tile. The geometry is such that the left extent of the texture no, to be honest, I don't know if there's supposed to be a gap here or not. Um, oh, but it's centered. Hold on. A drawable renders at a position to a width. Okay. So the furniture how do you draw yourself, Mr. Furniture? They're saying that this call here is like, okay, bind a GL texture, send geometry for x1, y1, x2, y1, x2, y2, x2, y1. So go to xy, and then go another left, or go to the right by half the width, and go up by half the height. Apply a rotation. We're not going to have a rotation. saying something about flipping. Not f dot flip. I'm not sure if that's going to be true or false. It strikes me as false by default. But we pass in not flip, and so this will be true. So we went to the right by half the width, and then we do it again. But we undo. Eh? We need to test that render advanced works for flip not flip. Um, I don't understand why this is not symmetric. Um, this will take the geometry that comes in and move it to the right by x, and then move it by half the width, and then move by half the width again, and then scale everything in the x direction. Okay, yeah. Scale everything by dx so that when they send a 1 in the texture or in the call list, the command list, the display list, whatever it is, uh, the 1 becomes the full width, but it becomes minus the full width. So at least in terms of exit is we take we move to the right by the x offset. We move a little bit to the right by half the width. We move a little bit again, and then we draw such that the total width is covered to the left. Okay. Otherwise, we move to X, move by half the width, and then we undo the move by half the width, and we say, draw it this way. That makes sense. This is move up by Y, move up by half the height, move down by half the height, and then draw in unit of one height. This is move up by half the height, move down by half the height. So again, back to Y, and then draw up. I guess the flip is only horizontal flip. Okay. It's always going to hit x to x plus dx and y to y plus dy. Sure. But the dy and dx that we throw in, this width is really in terms of board space units. We use a float because we want to be able to do non-whole units. You want to cover half a tile or 3.5 tiles. For the column, it's going to be 1. Why is it going to be 1? It's going to be 1 because render drawables uses a width of dx, which is just the dimensions of the thing we're drawing. The x component of the dimensions that we're drawing. So when a furniture returns dims, it returns this orientation's dx and this orientation's dy. If they flip, then it's the other way around. But dx dy is 1 by 1. So that's in board space units. So okay, width is going to be 1. Orientations. Rotation is going to be 0, I believe. But like it's the same either way. This is a 1. This is a 1. This is a 1. That's a 1. What if we did something like this, these are the x values. Yes. Uh, many columns, please. I'm gonna have to call it pretty soon. There's a problem with that. They should be along the diagonal. We're not rotating. I'm gonna have to call it here, but that should help us hone in